next reaction in electrophilic substitution reaction is Friedel-Crafts reaction. So let's see how the reaction is taking place in the case of Friedel-Crafts reaction. It is of two types. One is Friedel-Crafts alkylation, second is Friedel-Crafts acylation. These reactions are also occurring in the presence of Lewis acid like AlCl3, FeBr3 or FeCl3. These Lewis acids are behaving as a catalyst in the reaction, which is initiating this electrophilic substitution reaction in arenes. So let's see how the reaction is taking place in the case of Friedel-Crafts alkylation. So first is Friedel-Crafts alkylation. So what is happening in this case? First of all, you have to write the general reaction, then further you will do mechanism of the reaction. So what is happening in this case? First of all, benzene is reacting with methyl chloride. So this is Friedel-Crafts alkylation, because in this case this alkyl halide, that is alkyl part of the alkyl halide, will be introduced in benzene ring, that is arene. So this is known as Friedel-Crafts alkylation of benzene ring. So what is happening? This reaction is taking place in the presence of anhydrous AlCl3, which is Lewis acid. It is electron deficient, so it is behaving as a catalyst. So what is happening in this case? For final product which will be obtained is toluene, and there is removal of HCl. In Friedel-Crafts alkylation, there is very important point that in the case of alkyl halide, first of all, you know that this anhydrous AlCl3 will initiate the reaction. So what is happening in the presence of AlCl3? This will help in generation of carbocation. So that carbocation will attack on the benzene ring. So what is happening? If there is some alkyl chain which is present and the carbocation which is formed in the presence of this anhydrous AlCl3, then if that carbocation is not stable, you know that the stability order of carbocation is more stable, is 3 degree, then 2 degree, then 1 degree, and then methyl carbocation. So if longer chain of alkyl halide is present, then more stable carbocation will be formed. It means there will be rearrangement will be taking place either by the help of 1,2 hydride shift or by the help of 1,2 methyl shift. So these type of rearrangement will be taking place, which will form more stable carbocation. Then that more stable carbocation will attack on the benzene ring. So what is happening in this case? If we use chloropropane as alkyl halide, so what is happening? In this case, you know that in the presence of anhydrous AlCl3, there will be formation of this anhydrous AlCl3 will help in generation of carbocation, formation of carbocation. So the carbocation which will be formed is primary carbocation, and you know that primary carbocation, that is 1 degree carbocation, is less stable. So what is happening? There will be 1,2 hydride shift will takes place. It means the carbon which is next to this carbocation, so what is happening? The hydrogen of this carbon, second carbon, will be shifted to this first carbon which is electron deficient. So this is known as 1,2 hydride shift. So what is happening by this hydride shift? There is a formation of more stable, that is, this is 2 degree carbocation. So there is formation of more stable 2 degree carbocation is taking place. Further, this 2 degree carbocation will react with benzene, and there is a formation of C6H5CH, CH3, CH3. Similarly, if we take this compound, so what is happening in this case? There will be first of all anhydrous AlCl3. In the presence of anhydrous AlCl3, there will be first of all there will be formation of carbocation is taking place. It means CH3, 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 CH2, plus. We know that this is a 1 degree carbocation, and we know that 1 degree carbocation is less stable, so there will be rearrangement is taking place. This time the carbon which is next to this carbocation, it means this carbon, second carbon, is having methyl instead of hydrogen. So what is happening in this case? There will be 1,2 methyl shift will be taking place. It means this methyl will be shifted towards this. So there is 1,2 methyl shift is taking place, and there will be formation of CH3, CH3, CH2, CH3, and this carbocation will be taking place, and this is tertiary carbocation, that is 3 degree carbocation, which is more stable. And this more stable carbocation will react with benzene ring, then this alkyl part will be introduced in benzene ring. So in the case of alkyl halides, if there is a probability of formation of more stable carbocation is there, then there will be rearrangement will be taking place by 1,2 hydride shift or 1,2 methyl shift, then there is formation of more stable carbocation will takes place, and this more stable carbocation will be introduced in benzene ring. Now in the case of Friedel-Crafts alkylation, the general reaction is this. So what will be the mechanism behind this reaction? We have earlier seen the mechanism in the case of electrophilic substitution reaction in benzene. Similar mechanism will be applied in this case also. So there will be generation of electrophile in the first step. So in the case of anhydrous AlCl3, this will help in the generation of electrophile. So what is happening in this case? Methyl chloride in the presence of AlCl3. So there will be formation of polarized molecule will be taking place. It means CH3, Cl. So there will be separation of charges. It means the molecule will get polarized. It means there will be partial positive charge on this carbon and partial negative charge on this part. So this is a polarized molecule which will further initiate the reaction. In the second step, what is happening? In the second step, there will be sigma complex formation, that is carbocation formation. So what is happening? In the case of benzene, there is pi electrons are present. So these pi electrons are loosely held electrons. So the electrophile will get attracted by these loosely held electrons. So what is happening? Polarized molecule, pi electron will be attracted by this methyl cation. So this bond, this weak bond will be removed. So there will be formation of and because this pi bond is shifting towards this methyl, so what is happening? There will be positive charge on this carbon of the benzene ring, and there is one more hydrogen present on each carbon of the benzene ring. So in this case, there is one hydrogen and one methyl, and positive charge is coming on this position. So this is a sigma complex, that is carbocation. So this sigma complex is resonance stabilized. So this bond will be shifted towards this. So there will be formation of second canonical structure. So when this bond will be shifted towards this, so positive charge will be coming on this carbon. So in this position, there will be positive charge. And in this position, there will be bond formation. So this is first structure, this is second canonical structure, third canonical structure, carbon position. So there is partial delocalization, and this is resonance hybrid. Third step, there will be removal of proton will be taking place from the sigma complex, that is this sigma complex. So what is happening in this case? This, in the presence of this AlCl4 minus, this AlCl4 minus will abstract this hydrogen as H plus. It means the shared pair of electron of carbon hydrogen bond is shifted to this position. So in this case, there will be removal of H plus will be taking place. So there is a formation of toluene. This methyl benzene is taking place, and removal of AlCl3, and HCl, because we know that when the reaction is complete, again catalyst will be regenerated in the completion of a reaction. So this is the mechanism of reaction. In this case, the second step is the slow step. This is rate determining step. Why this step is slow? Because more stable benzene is converted into less stable carbocation. So this is slow step, rate determining step. Whereas in the third case, less stable sigma complex is converted into more stable toluene. Because of that, this step is fast. It is not a rate determining step. Next is Friedel-Crafts acylation. In this also there will be catalyst used, that is AlCl3 or FeBr3 or FeCl3. So these catalysts are behaving as a Lewis acid, which will help in generation of carbocation. So in this case, there is introduction of acyl part on the benzene ring is taking place. So let's see how the Friedel-Crafts acylation is taking place. First of all, you have to write the general reaction. So what is happening in this case? So this reaction is taking place in the presence of acyl chloride. This is acyl chloride. So what is happening? This reaction is also taking place in the presence of anhydrous AlCl3. So there is formation of COCH3, that is acetophenone, and removal of HCl. Similar reaction will also takes place in the presence of acetic anhydride. If we use, instead of using acyl chloride, we can also use acetic anhydride. So what is happening in this case? There will be formation of, first of all, this is acetic anhydride. This is acetic anhydride. So what is happening in the presence of anhydrous AlCl3? So there will be cleavage of bond will be taking place. This part will be introduced in the benzene ring, whereas this part will be removed. So there is formation of acetophenone and removal of acetic acid. Similar mechanism will be occurring in this case also, as we have seen in the case of Friedel-Crafts alkylation. It means in this case also there will be 3 steps in the mechanism. So first step will be, there will be generation of electrophile. So what is happening in this? CH3COCl in the presence of anhydrous AlCl3. So there is a formation of, as we know that this AlCl3 is behaving as a halogen carrier. So this Cl will be removed as Cl minus. So that will be abstracted by AlCl3. It means there will be formation of AlCl4 minus is taking place on the right hand side of the reaction, and positive charge will be coming on this carbon. So this is acyl part. So what is happening? CH3 C double bond O plus. We know that in the case of oxygen there is 2 lone pairs. So this acyl part is resonance stabilized. So what is happening? This lone pair will be moving to this position. Because of that, there is another canonical structure will be formed. So positive charge will be coming on this oxygen. Positive charge of this carbon is dispersed by this oxygen lone pair. So there are 2 canonical structure. It means this is resonance stabilized. So first canonical structure is this, second canonical structure is this. Because there is presence of pi electron in the case of benzene ring, so it is attracted by electrophile. So in this case the electrophile is acyl part. So what is happening? This pi electrons are attracted by this acyl part, that is carbon. So there is a formation of sigma complex, or we can also say carbocation is taking place. So there is formation of this carbocation, and every carbon in the benzene ring is attached by the hydrogen. So it means there will be 1 hydrogen is also present, and this acyl part will be attached to this carbon position. So this is carbocation, which is sigma complex, which is resonance stabilized. So there are 3 canonical structure will be formed, as we have studied earlier. So just form the 3 canonical structures. So this bond will be shifted to this position. So positive charge will be coming on this position. Second canonical. Third structure is resonance hybrid. So what is happening in this case? There is partial delocalization. It means from this carbon to this carbon there is a delocalization, that is partial stabilization of the positive charge. This is resonance hybrid. So in third step there will be removal of proton will be taking place from this sigma complex. So how this reaction is taking place? We know that in the second step there is formation of AlCl4 minus. So what is happening? AlCl4 minus will abstract this proton which is bonded with this carbon, and shared pair of carbon hydrogen bond will be shifted to this position. So there is formation of acetophenone is taking place. This is acetophenone, and removal of AlCl3 and HCl. Last electrophilic substitution reaction in arenes is sulfonation. It is similar like the nitration. So what is happening in this case? First of all, before writing the mechanism, you have to write the general reaction. So what is happening in this case? Either we can use chlorosulfuric acid, or we can also use fuming H2SO4, which is also known as oleum, that is H2S2O7. So what is happening in this case? In the presence of fuming H2SO4, the reaction temperature is 330 Kelvin. So there is formation of, that is introduction of sulfonic group is taking place. So introduction of SO3H, this is benzene sulfonic acid, and removal of H2O. Reaction is also taking place in the presence of chlorosulfonic acid having formula ClSO3H. The reaction, that is the reaction is taking place at 330 Kelvin temperature. Similar reaction is taking place. There will be introduction of sulfonic group in benzene ring. Benzene sulfonic acid will be formed, and removal of HCl. In the generation of electrophile, 2 molecule of H2SO4 will be taken. So there is acid base equilibrium will be taking place. So there is formation of electrophile SO3. This is electrophile which will be generated during this acid base equilibrium reaction, and removal of HSO4 minus and H3O plus. This molecule is resonance stabilized. So this bond will be shifted towards this oxygen. Oxygen will take away the shared pair of pi bond towards itself. Because of that, there will be negative charge on the oxygen and positive charge will be coming on sulfur. This negative charge will be shifted towards this, and this pi bond will be shifted towards oxygen. So there is resonance stabilization of this electrophile is taking place. So there are 4 canonical structure will be formed in this case. Further, this negative charge will be shifted towards this position, and this pi bond will be shifted towards this. So there are 4 canonical structures are formed, and positive charge in this canonical structure is coming on sulfur. So this sulfur is behaving as an electron deficient. So what is happening? We know that in the case of benzene there are pi bonds which will attract the electrophile, and this sulfur is behaving as an electron deficient part. So it will be attracted by the electrophile. So this pi bond will be shifted towards this. So we know that in each carbon there is one hydrogen, and because this pi bond is shifted towards this, because of that there will be positive charge coming on this carbon. This reaction is reversible. This reaction is reversible. There will be formation of sigma complex. So there is formation of sigma complex is taking place, which is resonance stabilized, and we know that in the first step in the generation of electrophile there is HSO4 minus. So what is happening? This HSO4 minus will abstract this hydrogen. So this HSO4 minus will abstract this hydrogen of this carbon hydrogen bond. So the shared pair of electron of carbon hydrogen bond will be shifted to this position. So there is formation of this anion is taking place. There is still oxygen is having negative charge and H2SO4. This benzene sulfonic anion, this negative charge of the oxygen will be neutralized by the H plus, which will be provided by this hydronium ion. So there is positive charge on the hydronium ion. So this bond, that is hydrogen oxygen shared pair, will be shifted towards the oxygen, and this hydrogen will be abstracted by this O minus. So further there is formation of benzene sulfonic acid will be taking place and removal of H2O. In this case, the equilibrium is shifted backwards, because this sulfonic acid SO3H, this SO3H part, that is sulfonic acid, is very strong acid. It means this sulfonic acid will easily release H plus and there will be formation of benzene sulfonic anion. It means this benzene sulfonic anion is more stable in comparison to this benzene sulfonic acid because it is a strong acid. So this reaction, the equilibrium of this reaction is shifted backwards. Because of the reversibility of sulfonation, this benzene sulfonic acid is less stable. Because of that, this sulfonic acid part can be easily removed from this compound. So this reaction is taking place in the presence of steam and H plus ion under high pressure. So under high pressure, in the presence of catalyst, this H plus ion is behaving as a catalyst, and steam, this benzene sulfonic acid will dissociate to form benzene and H2SO4. So this reaction is known as a desulfonation.